Hey, hey, hey. Today we are going to learn about measuring. Now, some of you are pretty good at measuring already, but there's still something you could learn. We, in this country, the United States, we measure by using these items. These are measuring cups. And that is called measuring by volume. So we fill up the measuring cup, and that makes a cup. In Europe, they measure not by volume, but by mass, or we would call it by weight. So everything they do, they measure on a scale. At least that's what I understand. I could be completely wrong. All right. Um, so here in the United States, to measure 1 cup of flour or sugar, we would take a dry measuring cup. These are dry measuring cups, and I'll show you why in a second. These are liquid measuring cups for measuring liquids. So to measure 1 cup of flour, we take the scoop and we overfill the measuring cup with flour till it's overflowing, thus the term overfill. Then we take our straight edge spatula and scrape it off so it's completely flat with the top. That's 1 cup of flour. We do the same thing with sugar. Sometimes these aren't always handy, so what we can do is fill it overflowing and use the scoop to level it off. Um, this is more accurate than scooping and scraping because the act of scooping compresses the flour inside the cup. So it's better to, or it's more accurate, I should say, to fill it to overflowing with the scoop and then level it off flat. Um, I have seen people fill it not to overflowing, scrape it off so it's level and flat, and look what happens. It's not even full. To get a full cup measure, you have to fill it up, scrape it off so it's level with the top of the measuring cup. Okay? Flour and sugar, same thing. Now, I've seen people do this. They take their straight edge spatula and they go like this, sideways. They don't go up and down, they turn it sideways. They scrape like that. And in this case, it worked, but quite often the flour will fall over the top and back into the measuring cup. Okay. Why do we care? What difference does it make? Well, the difference is, and that's a good question. Whenever we do something that we don't understand, it's a good idea to ask, what difference does it make? Um, Good cooking is the product of lots of good steps. So if every time you measure something you say, close enough, what difference does it make? I don't really know. Then your product's going to be like, I don't really know. But if you pay attention to details all along the way, your final project will be better. If you measure correctly, pay attention to your temperature, pay attention to time, all the directions, and you follow them exactly, you're going to have a much better product. Now, I told you that's how we measure flour and sugar. Sugar is identical to the same way we measured flour just a minute ago. But what is completely different is brown sugar. And let me show you. I got a bowl of brown sugar here. And when we measure brown sugar, we pack it in as tight as we can with our fingers. Let me show you. Okay. And this, we don't need to use a scoop. All right. Now, you might think, oh, that's pretty full. Okay, that's a cup of brown sugar. No, the standard for measuring brown sugar is we push it in as tight as it will go. Now, I told a student like this once, and he said, okay, I packed it in. Let's go. No, the reason we pack it in is so we can get it completely full. So you want to pack it in as tight as you can with your fingers and squeeze it on in there. If you can pack in more, then you don't have enough brown sugar in there. When you dump this out, if you've done it right, it should retain its shape. If you dump it into a container or a bowl or whatever, and it instantly falls like this, then you haven't packed it in enough. And the packing is just so you get enough brown sugar in to make the measurement accurate. It's a standard. So when they wrote the recipe, whoever wrote the recipe wrote it assuming that you would pack your brown sugar in like this. Yes, you're going to put more brown sugar in than you would white sugar, but this is the standard that we go by, and this is how we know we've done it correctly. For liquids, we use a liquid measuring cup, which looks like this, or this, or this. This here is a 4-cup liquid measuring cup, or what is that? 1 quart. This is a 2-cup liquid measuring cup, or 1 pint. And this is a 1-cup liquid measuring cup. So we measure our liquids by filling up to whatever mark is on the side of the cup. Now, it's best to put it on a table flat, like this, and get down at eye level and see if you're matching up with the line. If I hold it up like this, look how crookedy it goes. Again, if you pay attention to correct measuring throughout the cooking process, then your product's going to be a little bit better. So instead of holding it up like this, to look at it, put it on a flat table and get down and look at it. That's how you measure liquids with a liquid measuring cup. Now, one thing you might find interesting, I certainly do, is that quite often liquids in the United States are measured in ounces. You can see this right here. Up to this line, it's kind of hard to see. Maybe if I do this, it says 16 ounces. Okay. Now, why that's interesting, and in fact, why it's confusing, is because those are fluid ounces, and we measure liquids in fluid ounces. On a scale, we also measure with ounces, but it's not fluid ounces. It's dry weight ounces. What difference does it make? I'm glad you asked. Because, as you can see here, this is 32 FLOZ. That's 32 fluid ounces, which is 1 quart. This does not weigh on a scale 32 dry weight ounces. Let me show you. Can you see that at all? It says 35.55 ounces. And the reason that is because different liquids have different densities. What is a density? You ever heard that old riddle, which weighs more, a ton of bricks or a ton of feathers? Well, the answer is neither weighs more. They both weigh a ton, 2,000 pounds. But they are in fact different because a ton of bricks I can fit on a very small space. I can fit a ton of bricks on a skid, on a pallet. But a ton of feathers takes up a lot more space. They both weigh 2,000 pounds, but one takes up a lot more space. The one that takes up a smaller space is what we call more dense. I put an apron on because this could get messy. All right, so what does that mean? So different things have different densities. Well, I have a scale here, and it's hard to put the scale. Well, I could use this scale. I'll use this scale, which we're going to talk more about in depth in a few minutes. Um, this scale, because it uses springs and heat causes springs to expand and contract, um, there's this dial here that helps you adjust it based on the weather. So before you start, you want to turn that dial till it points exactly to 0. All right. So how does density affect things? Well, here's a cup of marshmallows, and it weighs just a hair under 1 pound. Now I'm measuring the cup as well. Here is a cup of iced tea. That weighs almost 1.5 pounds. And here is a cup of oil. That weighs a little bit less than the iced tea. Iced tea is like over 1.5 pounds. It's kind of hard for me to see. Oil is like a little bit less than 1.5 pounds. So what that means is if I put the oil and the iced tea together, because the oil is less dense than the iced tea, what's it going to do? It's going to float on top, right? So let's see if that's in fact the case. So I put a little bit of oil in here because the denser things are going to go to the bottom. And oil and iced tea don't mix. So we'll give that a few seconds to stabilize. And this has to do with density. Iced tea is more dense than oil. And ice, you may be able to see there's ice cubes in this iced tea. They always float on the top because ice is less dense than water. Gasoline is less dense than water, so that's why when they have oil spills in the ocean, it floats on top of the water, it doesn't go to the bottom. Mercury is very much more dense than water, so any mercury that we have on land goes down, down, down into the ocean, to the bottom of the ocean, and sometimes fish eat it, and that's why we have to be careful with mercury poisoning with some fish, because the fish eat the mercury. Birds don't eat mercury because they're up here. But mercury always goes down because it's extremely dense, and it's going to find the lowest spot. And here in the desert, it'll go on the, if you drop mercury, it'll go on the ground, and then the wind or people will kick it, and it'll go to a lower spot and a lower spot, and eventually it'll find its way, after years and years, find its way to the Mojave River, and that'll go to the desert where the Mojave River stops. That's not a good example. But if we lived closer to a river that went to the ocean, that mercury would follow the riverbed all the way to the ocean, and then it wouldn't stop in the ocean. It would go to the lowest point in the ocean. Alrighty, so more dense things sink to the bottom. Can you see that now? And less dense things float. The oil is less dense than the tea, so it goes to the top. All right, so what does this mean? Why do we care about density? Well, I'm just explaining to you why 32 fluid ounces of, this is vanilla, artificial vanilla, is going to weigh differently than 32 ounces of oil or 32 ounces of marshmallows. So why is that important? Because when you go and buy yogurt, let me show you. Okay, when you buy some dairy products, you might think, oh, this is 32 ounces. You see that? 32 ounces. It must be the same as this. Well, this is not full, actually, so let me get one that's full. Okay, so this one's full. This is 32 ounces, and here's how you can tell. It says 2 pounds. So that doesn't say fluid ounces. This says 32 fluid ounces. Okay, so that's measured by volume, measured in a measuring cup. This is measured by weight on a scale. And so they might be close, but they might be different as well. So let's see if they are in fact different. So this should say 2 pounds. Now I've overfilled it, so it's actually a little bit more than 2 pounds. And this is about the same. But as you can see, oh, if we were to make this so it equaled exactly 2 pounds, let's just play with this a little bit. This is not accurate measuring, but we just made that. So pointed exactly at 2 pounds. Pretty close. In this case, they're pretty close because they're both mostly water. But that doesn't always work that way. Imagine if this were filled with air, which when it's empty, it will be filled with air. It'll still contain 32 fluid ounces of air, but it's going to be very light. Or if it's full of helium, it's going to be lighter still. Fill it up to the top, it's 32 fluid ounces of helium, but it's going to be very light. Whereas if I filled it with mercury, it's going to be very heavy because mercury is much more dense. Well, that's a little bit about density and measuring. So I picked up this scale right here on eBay, and it's kind of an interesting scale because it measures volume based on weight. Now, like I said, in this country, a recipe quite often gives you measurements in volume, cups and tablespoons, etc. But there is a formula that you can calculate if you know the substance. You can calculate how much something weighs based upon the volume of that substance. So, for example, I'm going to try and get in real close here. No, it's not going to be helpful, is it? Okay. You can see here where if you put butter on here, it'll tell you based upon its weight how many cups it is. Like this line right here is 2 cups of butter. But 2 cups of flour, oh wait, where's flour? Flour's black. I can't even see it. Flour is like right here because the density of the two items is different. But this scale takes that into consideration. Sifted flour is lighter and fluffier because there's more air in it. So it's going to weigh less. Buttermilk, and it also says milk and water, they're all pretty similar in density. You can measure it by its weight and know how many cups it is. So here's 1 cup of buttermilk compared to 1 cup of flour. So you can use this to, in fact, measure volume. It's just a kooky little scale that I found on eBay, and we're going to test it and see how well it works. Now, before we test it, there's something I want to talk to you about called tare, T-A-R-E, tare. And that is, if I were going to measure the weight of these marshmallows, first, I make sure my dial is on 0. And this one has an adjustable dial too. I'll show you why in a second. Okay. All right, this is almost 2 pounds. But is that 2 pounds of marshmallows? Why not? Exactly. The container weighs more than the marshmallows. So we do something called tare. In other words, we calculate for the weight of the container. And the way we do that with this scale is we start with an empty vessel, which is our measuring cup here, and we turn it all the way till the needle points to 0. Then we add our marshmallows, and you can see it just moved a few dry weight ounces, because the cup or the vessel weighs a lot more. So we've taken into account the weight of the vessel. Now with this measuring instrument right here, this scale, I'm going to show you how we use it. We start by turning it on. Okay, and it should show 0. It's giving me an error code, but that'll go away in a second. I think it might need new batteries. Let me try it again on a flat surface. All right, so I don't know if you can see that, but it says 0. So it's ready to measure whatever I put on it. But to calculate for tear, what we do is we start with the measuring cup, we put it on the scale, and then we hit our power button. And when that goes to 0, we add our marshmallows, and we find out that's 1.58 ounces. Pretty cool, huh? And it says tear here because it knows that we've calculated something. We turned it on when there was a vessel on it. If I just turn it on now, it's going to give me straight measurement. But if I put a vessel on it and then hit power, it's going to give me a tear weight. One other thing I want to point out to you is in the upper right-hand corner, I can adjust for units. So right now it's set to ounces. So it's just straight ounces. So 29.2 ounces. I can switch it to milliliters. I can switch it to pounds and ounces. So that's 1 pound, 13.1 ounces. Or I can use metric system with grams. So in this class, whenever we use this, we will always use straight ounces. All right, as I bought this thing as sold as an antique, I don't know how accurate it is, so we're going to find that out together. It's probably from the 1940s or 50s, and it could have been accurate at one time. I mean, if it's not accurate now, but springs get sort of soft after time goes by and other things happen. So there we are, set at 0 pounds and ounces. So what we're going to do first is we're going to measure cups of sugar. So let me set this to 0 a little bit better. It's kind of hard for me to see it in the camera. There we go. All right, we're going to do that first. First thing I'm going to do is put the cup on here and adjust my tear weight, which is pretty small. I'm going to adjust it from this angle. There we go. Now I'm going to put sugar in here. An exact measure of a cup of sugar. See how accurate this puppy is. So, sugar, I'm pretty close to being on the line. It's a little tiny hair off, but pretty darn close. That's pretty impressive. Let's see how it does with the flour. Now I don't need to adjust the tear because I'm using the same measuring cup. And let's see how accurate the flour is. This is unsifted flour. And flour is the black line, and there it is. It's off just a little bit, but pretty darn close. I would say this is a pretty accurate measuring tool, even after all these years. It will also work on milk or water, sifted flour, all-purpose flour, which is what we're using. Let's see how it does with butter. So give me a second. We'll see how that works. All right, here we have 16 ounces or 1 pound of butter. It doesn't say fluid ounces, so this is dry weight. Now, you might be tempted to melt this down and think that it weighs, or it takes up 16 ounces of space in a measuring cup. And it may, I don't know, but I wouldn't depend on it. I would experiment with that before I tried it. Don't assume that 16 ounces dry weight is the same as 16 ounces of liquid. So first thing I want to do is adjust the tare, because we don't have a vessel this time, just the paper, and that's negligible. All right. And we're going to put our butter on here. And butter should be the yellow band. And this appears to be a little bit off. It says it's 2 pounds and a quarter, 2.25 pounds. Well, that's interesting. Seemed to be accurate for the flour, seemed to be accurate for the sugar, but it didn't seem to match the butter. But let's see if, in fact, we're correct with the butter. Okay. So this time, I'm going to turn my scale on. Oops, I'm going to turn it on. Come on. The battery must be getting weak. I'm going to turn it on. There's no tare there. And it should come out to 16 ounces. But it actually says 16.29 ounces. So this is a little bit over a pound, according to both of these scales, because the Cookometer, didn't I say it was 1 pound and a quarter? Or what did I say? It was 1 pound and a quarter, and this says at 1.29 pounds. Or 16 ounces, 0.29 ounces, 16.29 ounces, that says. And this one says, just a recap, it says 2 cups and a quarter of a cup. So butter, sometimes recipes ask for a pound of butter, but usually they ask for cups of butter. Now, when we measure butter, 1 pound is 2 cups. Now, I get this from a food supply company, but oftentimes you guys will have the butter you buy in the store will be in sticks. Let me show you that. I don't have any sticks. Sorry about that. But a pound of butter, like I showed you, is actually cut into 4 sticks, and each stick is half a cup. So 1/2 plus 1/2 is 1, plus a 1/3 half is 1 1/2, plus a 1/4 half, 4 times 1/2 is 2 cups. So let's just do a quick recap before I close this out. Dry measuring cup for measuring flour and sugar. Make sure you use a straight edge spatula to level off the top. Liquid measuring cup for measuring water, juice, milk, buttermilk, or oil. I forgot to mention, this is accurate because we fill it up to the very edge and scrape it off level with the top. We could do that with liquids. In fact, when I was a kid, this was the kind of measuring cups I had in my home. And that's all I had, so I had to use it for measuring liquids. The problem is, to be accurate, you have to fill it up to the very edge, and then you're going to spill it. I don't care who you are, you're going to spill it. Maybe you'll spill it in the bowl, but you're going to spill it somewhere. For liquids, we're not going to do this. We're just going to fill it up to the line. And because it has a spout for pouring, can you see that? And since we're not going to fill it up to the very edge, just going to fill it up to the line, we can walk all the way around the classroom without spilling a drop. So that's why we use liquids for this. And dry ingredients, we use this. So since we got both, we're going to use the correct tool that's been designed for the substance. If you're at home and you got just one of them, by all means, use what you got. Okay, density is in scientific class, we call it mass per unit volume, but it's basically not just how heavy something is, but how tightly packed it is, or how it's such a small area. Because a ton of bricks and a ton of feathers both weigh a ton, 2,000 pounds, but a ton of bricks is in a much smaller area than a ton of feathers, because bricks are more dense than feathers. And in this country, we mostly use measuring by volume when we cook. So we use measuring cups. In Europe, they use a scale. And that's nice because you don't have to have 3 liquid measuring cups and 3 solid measuring cups. You can just use whatever you got handy to do your measuring. The tare is when we take into account the weight of the vessel, and we do that by putting the vessel or the measuring cup or the bowl on the scale, on these electronic ones. After it's there, then we turn on the power and it gives us a tare, and we can measure accurately from that point. And we learned when we're measuring brown sugar, we pack it in tight, so tight so that when we dump it out, it holds its shape like a sandcastle. Not forever, but for a short time. And we learned about the cookometer, which is a way to measure out certain substances like flour, butter, milk on a scale without having to do any extra math. We could do it with this. We could calculate how much oil is in here based on its weight, but we'd have to do some math to do that. The cookometer does the math for us, and it just tells us how much butter we have. As a matter of fact, if we had liquid melted butter, we could put it in here once we adjusted the tare. Oops, wrong way. We could put melted butter in here until the scale read 1 cup. So that's an advantage to a scale like this. It does the math for you. All righty. Thank you so much. Thank you so much.